We'll keep things rolling here, and I would like to introduce our next speaker, MacKenzye Leroy. MacKenzye is a lead data scientist at S&P Global, where he works on AI-powered productivity solutions across the business. He's a graduate of the University of Virginia in the School of Data Science with a Master of Science degree. And when he's not working with data, he can be found exploring mountain trails by foot, bike, snowboarding, or reading, or cheering on his beloved New York Mets. So please join me in welcoming MacKenzye.
Thanks, Patrick. All right, thank you, everyone. So as Patrick said, my name is MacKenzye. I am a data scientist at S&P Global, and I do live and work in Charlottesville. So for those folks who are coming from out of town, to his point earlier, there's a great data science community here. Our office is on the other side of the mall. So another thing Patrick just mentioned is my team at S&P, we build productivity solutions. And today I'm going to talk about how we evaluate a lot of those productivity solutions we are rolling out. So specifically, a lot of these generative AI and large language model solutions. So it's a difficult task to evaluate those. I'm going to walk you through how we think about it and how we actually evaluate some of the applications we have in production. So with that, I'm going to go through the agenda. First, I'm going to introduce a tool, our MI Sales Assistant, briefly. I think this is the project that really started our evaluation work. This is really where it all started. So it's important to see what that tool is. Then I'm going to talk through metrics. Like everything else, you need things to measure against. And so we're going to talk about metrics for all the steps in a generative AI solution. I'm going to talk about how we generate ground truth data. So a lot of those metrics rely on really solid ground truth data. And then I'm going to talk about our actual technical implementation, the packages we used, how we're observing these tools in production, and then if I have time, just a brief talk about where we're headed next and some of the results that came from this. So with that in mind, here is the MI Sales Assistant tool. So my team at S&P Global, we are building tools for non-technical teams to really increase their productivity. So a lot of our stakeholders are in HR, finance, and sales. So this tool that we built is a RAG or Retrieval Augmented Generation tool. I'm not going to have time to get into the nitty gritty of RAG today, but if that is interest of you, I saw there's a really great session tomorrow and there's some other sessions. Only thing that's important to know is the way RAG works is you combine a large language model call with some additional context. So you grab some documents, you give those documents to the large language model and let them use that document as a reference to answer a specific question. So that's what our tool is. The really great thing about S&P is we have really good documentation about how our sales folks are supposed to do their job. So how they're supposed to engage with clients, how they're supposed to input data into Salesforce, how they're supposed to deal with legal. The problem was those documents were really federated. So there are a lot of different teams that manage different aspects of that process, and those teams maintain their own documents and have them in different spots. So it was really difficult for a salesperson to know, where do I go to answer a question? Sometimes they would know, sometimes they would have to submit a support ticket. So our tool kind of solved that. We worked with the sales teams, all of those individual teams, at the moment 8, but we're expanding to 11, to onboard those documents into a centralized place, this RAG tool, the MI Sales Assistant. And so now a salesperson can go to our tool and ask a legal question or a Salesforce question or a question on their commission structure and get an answer instantly. Now, you are all probably noticing one extreme risk with this tool right away, which is we're talking about legal documents, talking about policy documents, and so it's really important that our answers are correct. And so that's what has really sparked our interest in evaluating these tools, evaluating this tool in particular. Our stakeholders had essentially zero tolerance for risk on this. So again, the strength of the MI Sales Assistant, the fact that it covers so many different document stores, is also the biggest risk, making sure all of those document stores align. Okay, so now that we understand the tool, I'm going to talk through the challenges. I just laid one out. So in general, when dealing with large language models, one of those challenges is, that business impact can be significant if you have an error. Another challenge is language is really hard to evaluate. There are functionally infinite ways to say something that means the same thing, even if the word structure is completely different, even if the vocabulary is completely different. And so evaluating language as a whole has always been a difficult task. If we go a little deeper, if we think about RAG solutions specifically, there are two new problems. So one, you're no longer just looking at how well the model did, but you're also testing how well your retriever did. Did you search and actually identify the correct documents? You can't penalize the model for giving a wrong answer if it didn't have access to the correct documents for the question. And then the other thing is truth becomes relative once you're talking about a RAG model. So the example I'll use here is if you all were to go talk to ChatGPT today and say, what's a great color slide for a PowerPoint presentation? It might tell you yellow, it might tell you purple. In S&P, as you notice, we're sticking to brand colors. We have red and black here. So if we're talking about a specific S&P application, purple is not the right answer. Even though there's nothing wrong with purple, within the context of our business solution, that's not the truth anymore. So truth is relative when talking about RAG. And then if we talk specifically about our MI Sales Assistant, the tool I outlined for you all, there are two other problems. One is that truth changes. So the second a policy changes, we need to be able to update those documents and make sure that it's still accurate. So there's a time element, a temporal element to the truth in this case. And then the other thing is a lot of these documents are very dense and very complicated. So our team didn't really have the expertise to verify outputs from the tool. Frankly, they always looked good to us. We always thought that seems about right. I'm sure that's how you do that in Salesforce. So those are some of the challenges we're addressing here. So even though LLMs are new, even though generative AI is new, there are some things that are true, and that's you always need good metrics. If you're evaluating something, you always need something to measure it against. And so if we start with metrics, let's start with the retrieval step of the RAG process, because I think folks who have done data science before are going to feel very comfortable in this space. And that's because the retrieval step is really just a traditional classifier problem. Did we get the correct documents, yes or no? And so we actually have a lot of experience. I think most data science teams have a lot of comfortability in this space. We're talking precision and recall, F1 score, accuracy. All of those are still very relevant when dealing with a retrieval step for, large language models. Some things that you might tweak in the retrieval step would be the size of the chunks, the overlap, the number of chunks retrieved. Are you getting 5 documents? Are you getting 2? And then the actual embedding model that you're using. So again, I'm not going to dig too much into RAG, but just keep in mind the retrieval step is a pretty typical data science problem. The new space really is this generation step. How do we measure language? How do we measure the outputs of language? So it's not a completely new problem. There's been a lot of great thought on this for many years and decades. You can think of some of the more traditional statistical methods. So this includes BLEU and Meteor and Levenstein distance. These work well in certain constrained spaces. So these metrics are really looking at comparing token by token or word by word or character by character or n-gram by n-gram, how close your output is to another, to the expected output. The problem is, one of the strengths of large language models is we are kind of giving them free rein often. We're saying, hey, we actually want you to construct an answer that is reflective of what the person's doing. And so we don't want to constrain them to a very small space that says the output has to be exactly these words. And so one of the new insights, this is not from us, this is a huge thing in the space right now, is, and it was alluded to in the first talk, is using an LLM as a judge. That's kind of the newer frontier on evaluating these tools. So can we use an LLM itself to grade and score the outputs of an LLM? And so that's where there's been a lot of really great space, and that's where a lot of our metrics come from. I'm going to talk through some of the metrics we use. There are many others, so if you're interested, definitely reach out after. I know some folks in the audience, including Paul Arsenovic at S&P, has done a lot of great work on LLM metrics. But let's talk through some of the more simple ones and some of the ones we're using. So if we start with a metric like accuracy or correctness, what we're really looking for is the information factually accurate based on the source material? So an example question might be, how long is the Great Wall of China? We can see that second line is our source, which is saying it's about 13,171 miles. A correct answer would be something along the lines of it's 13,171 miles, regardless of how the sentence is structured. It just needs to be, is that the correct answer? So that's the idea of accuracy and correctness. That's a very broad one. There are really specific LLM metrics out there where you're identifying all of the facts within an output and checking all of them. This is just saying, on a whole, how accurate is this on a scale from, say, 1 to 5? An example of an incorrect one might be the Great Wall of China spans approximately 100 miles, obviously a factual error. So accuracy, correctness, I think most folks feel comfortable in there. Another important one, though, is relevance. So it's not just right that the model is correct, it needs to be answering the question at hand. So does the response address the question asked? Here's one. What are the steps to making sourdough bread? A correct answer would be making sourdough bread involves creating a starter, mixing ingredients, proofing the dough, and baking at high temperatures. That's a relevant and a correct answer. If we look at the second output, bread has been a staple food for thousands of years across many cultures. This is correct, but it's completely irrelevant. This is not what we want from that type of question. And then if we look at the last one, we have an example of a relevant answer that's completely incorrect. So this is why it's important to have multiple metrics. Making sourdough bread involves taking normal bread from the store and leaving it out until it sours naturally. That is not the correct answer, and I don't recommend anyone tries that at home. Okay, so we have correctness, we have relevance, we have similarity. So this is actually where those traditional metrics line up well. And this is how closely does the response match the meaning of reference answers. So here's an example. How do plants get energy? We have our source here outlining what photosynthesis is, and we have an answer that's very close. Plants transform light energy into stored chemical energy through the process of photosynthesis. A correct but not super similar answer might be plants get energy from the sun. Now this is a silly example, and really in our use case what we're seeing more is what our stakeholders like is they have these documents that say maybe have 10 steps involved. And they get a little wary when the model starts combining steps because often those steps align with discrete steps in a process. So maybe you're on a Salesforce page and you're going through 5 different pages. They like when the model has 5 steps involved and doesn't combine those into 3. It's a lot easier for the user. So this is a case where you get a correct answer, but you want to also make sure it is similar. And then finally, I think the one that gets a lot of headlines, rightfully so, is hallucination detection. So how do we make sure that it's not generating information not present in the source materials? So if we look at the same question, the same sources, and the same correct answer, an example of a hallucination might be plants transform light energy into stored chemical energy through the process of photosynthesis. They only do this on Thursdays, though. That's obviously ridiculous. We can identify right away that that's not true. But I will warn you, I've seen a lot of hallucinations now. They're almost never this obvious. A space where we see a lot of them is our documents are riddled with abbreviations, 3 letters, and the model loves to just decide what those abbreviations might be. Just read the document and think, oh, I think that it's these 3 things. Sometimes it's right. Usually it's not. Usually it's, and the worst part is it's a very plausible sounding wrong. And so that's where there's a lot of danger. Okay, so this is the idea behind using large language models as a judge, is we take the original question, we take our source, we take a ground truth answer, we feed this all to a large language model and have it rate the outputs across correctness, relevance, similarity, and a lot of other metrics. What you're probably noticing is in order to do that, we need a really good set of ground truth data. We need the model to know what's right, what's wrong, again, especially within our own contexts. So how do we generate this ground truth data? There's kind of 2 main ways to do it. One is if we're already using a large language model to evaluate the tool, and the tool itself is already a large language model, what's adding one more to the mix? So we can generate data with a large language model, and there's some real strengths to this. We can get a lot of a lot of data very quickly. But really, the gold standard for our generated data comes from our subject matter experts, our SME generated data. They understand the process, they understand where our users are most getting tripped up. They understand what common questions are. And so they're really good at generating questions. When we started this project, we were only using our subject matter expert data. The problem is those folks have day jobs at S&P that don't involve just making question answer pairs for us all day. And so it's really difficult and slow and burdensome on that team to ask them to generate large samples of data. And so what we have found is kind of combining these 2 methods is really the best way. So what we do is we have an LLM generate large lists of questions, and then we have the SMEs check their answers. We make sure that the questions are relevant to the source document. We make sure that the answers are aligned with the process. And again, this really takes a lot of stress off of them, because instead of asking them to generate 50 questions or 100 questions, we're having them check those. And it's a much faster process to check than to actually generate. At the same time, as I said, large language models are not perfect. They only have the small document in front of them. They don't have an understanding of the larger context. And so they struggle making really complicated questions, and they also don't know what users are typically asking. So we always complement these large language model questions with really specific, really focused SME generated questions. So these are how big, or these are bigger questions, more complicated ones that really align to the process. And we found that two-tier approach gives us very good generated data. Again, some really important lessons learned. SME validation is crucial. Sometimes the model, again, will hallucinate, or it will, or just generate questions that aren't particularly helpful. So we've seen ones that are like, how long is this document? And it'll tell you it's 3 pages. And no one's asking that. That's not something we're trying to test. So it's really important to validate that. And then it's also important to vary the models and prompt variation. So there's a really interesting paper out there right now that I have cited at the bottom here about how large language models favor their own output. So if you're using OpenAI models to generate questions, you're using OpenAI models for your tool and to evaluate, you're going to actually have biased output. So it's important to kind of mix models, maybe use an Anthropic model for one step, OpenAI for another, Llama, or if you have access to all of them or can, it's great to use a whole suite of them to get more of an average across that. And then again, mixing high level and very specific questions. The LLM does a good job at generating really specific, simple questions. Who do I contact about X? What is the definition of Y? But they struggle with those really complicated, broad questions. Okay, so we have metrics, we have ground truth data. How do we actually run the evaluation steps we're in? So we use a really great open source package by the name of MLflow. And so there are a lot of providers in the LLM eval space right now. I don't want to say MLflow is the only one. We looked at FM eval, deep checks, weights and biases, and a handful of others. I think all of them have their own strengths. For us, we really liked MLflow because it's open source, so our team could use it as need be. It is an AWS partner, so we actually run an MLflow server every day in SageMaker to run through this process. It's cost efficient, it scales really well, and has really good customization. So, for example, I went through some of the standard metrics, but given a specific use case, you might want a custom metric. For us, it was, did the model cite its document? That's a great example. We want all of our answers to have a document cited and a link to a document. So that's an example of a custom metric you could build into MLflow. Or did it always end the output with this link to redirect? And so we really like MLflow. And if you look at it, we run this every day, and you can see some of our experiments. What you'll notice is some of them take 30 seconds and some of them take 1 second. The 1 second is the retrieval step. Again, that's old school machine learning. Did we get the right documents? What's our precision? What's our recall? The longer ones involve OpenAI calls. They involve large language model calls. But it's got this really great dashboard to let you experiment this. It gives you an artifact so you can pull all of the questions, answers, outputs, etc. along the way. And it's got really nice built-in visualizations as well. We also then push all of our metrics to CloudWatch and AWS so we can track these metrics over time. Okay, so now that we've done that, let's go through the full framework of how we do this. So if we start all the way to your left over there with the source documents, we do 2 things. First, we run those source documents through a large language model to generate question-answer pairs. We also add it to the development or UAT version of our tool. And then we take those question-answer pairs and we work with our stakeholders directly to verify those and come up with a list of other suitable questions. We also have them use the tool a bunch, just press in whatever questions and answers you want and see if you find anything weird. That whole process gives us the ground truth data, these verified question-answer pairs that we can store and use for future runs. And then whenever we want to evaluate our tool, again, we use that MLflow server that pulls that ground truth data, runs all of our questions through the MI Sales Assistant, and then verifies that we're still online. So we don't run the whole process every day. That would be a little bit wasteful, to be honest. We think of it in 2 ways. One, we do a big comprehensive testing suite anytime there are fundamental changes to the system. So that would mean switching models. That means switching prompts. That means adding a large set of documents or subtracting large documents or changing structurally a lot of the documents. Okay, so what we'll do is we'll run a comprehensive suite whenever that changes, and that gives us our baseline. Then from there, we do daily testing of about 20 to 25 stratified samples. We'll run across all of our stakeholders, grab a few questions, and make sure that we're still getting the expected output and that the accuracy is still within the realm of our baseline. So if a document was only getting a 4 out of 5 on our baseline, and now it's getting a a 3.8 out of 5 when we test on that day. That's not necessarily something to worry about. But if it's now getting a 0 or a 1, that's something we want to be digging into. So this helps us just verify the system's up and running and helps us detect early warning signs of performance issues. Sometimes these things drift over time. And then talking about the results from that. First, obviously faster problem detection. So we're able to identify things more or less as soon as they happen, or in most cases preemptively. We're able to identify problems we weren't able to before the tool is even released, while we're still in the user accepted testing phase. And so that's huge. It gives our stakeholders a lot of confidence in the tool that we've already run it through these suites and that we're running it through every day. And then the other thing is it's really accelerated our deployment of new documents. So I mentioned we're working with 8 teams, each one with a big set of documents. We're expanding to 3 right now. And when we first started this process, it would take us, over a month often to work with that team closely and get those documents actually integrated. Again, because there was really no margin of error. No margin of error. We wanted really specific answers. Now, with our step where we can generate question answers and run through this framework, we're able to do this often in less than 2 weeks, onboarding new sets of documents. And we've reduced the actual number of hours required by our SMEs by over 70%, again, because they're now mostly checking answers instead of actually generating them. And then something that we didn't expect but came out of this is we actually got knowledge base improvement. What I mean by that is while running this test suite, we were able to identify documents across different teams that were conflicting with each other. So legal is saying one thing, but this other team has a small reference to a legal process that's outdated. That would have slipped by before, but now we're able to see, oh, this is causing a real issue. We're able to get to those teams faster, figure out what is the actual policy. Is it this old one? Is it this new one? Who's responsible for this? And rectify that quicker. So we've had a lot of really good knowledge base improvement based on this tool because we're able to identify those problematic documents. So it's been really helpful for us. We're expanding. First thing is we're generalizing more. We want to use this framework across more of our GenAI tools on our team and across MI in general. We're also working on kind of expanding what I just outlined, that ability to identify problematic documents within doc stores. So making that more of a feature instead of just a pleasant outcome. We're also adding security checking. So now that we're feeling good about the performance, there are plenty of other things to check about an LLM tool. Is it vulnerable to prompt injection? Is it vulnerable to toxic inputs or outputs? Is it vulnerable to issues with PII? So we're adding that as part of our testing suite as well. Our long-term vision is we'd like to have a standard evaluation tool and dashboard across all the GenAI tools. So with that, I want to have some special thanks. So the team leadership on this, Alec Goss and Ming Yu, who are in the room. And then I want to thank some of our folks in Hyderabad who weren't able to join us, especially Shravan Karnina. He's the technical lead on this project. Most of the actual implementation was done by him, but also Sai and Dristi on our team made a lot of really great contributions to this project. So I want to thank all of them. And with that, go do any questions if we have time.
And we do have a few minutes for questions. So, yes, here in the front.
Thank you, Leroy. It was a very good presentation. I really appreciate it. So you had talked about the improved step where instead of the SME actually generating these pairs, the question and answer pairs, that would take so long, you talked about a little bit more of that. So I was hoping you could walk through almost like a comprehensive use case. Suppose you have SME and they have created 20 videos, 20 podcasts, and 20 papers, right? And they come to you and they say, I would like an LLM on this corpus. Now you're going to say, okay, let's go through it. Could you just walk me through from a high level those steps for that general use case?
Walking through a new use case in 60 seconds or less.
Okay. Yeah, so first thing is you mentioned video and podcasts. We're not really supporting that at the moment, but first thing would be getting a text transcript naturally, something that a large language model could read. We're going to feed singular documents or sources, if you will, at a time to the large language model and have it craft question answer pairs. The reason you want to do basically that single document at a time is that's what's getting you the data for the retrieval step. So you generated this question and this answer based on this document. When we ask that question later, you want to be going back to that same document. So we generate those, we save those questions, we save those answers. We then, have a comprehensive suite, we basically have a tool where we let our SMEs see all that data we generated and provide their feedback. So sometimes that's just yes, no, but then often there's some nuances to it. So we mostly like this answer, but maybe this question or this part of it isn't right. And then, frankly, what that often means is us updating the documents. So we explain to the SMEs, usually the reason that happens is there's something wrong with the document or not in there. So they'll go back, they'll update the document, we'll run it back through the pipeline and do that process again. So it's very iterative. Lots of times we're running through new questions, and then over time, stakeholders, we have check-in periods with them even after they're done with that initial batch to see if there are documents that need to be pulled, documents that need to be added, and if we need to run anything else through the pipeline. I hope that answers your question, but I was trying as best as I could in 60 seconds or less.
Nicely done. All right, over here by the aisle. So if one of the tests in your test suite fails, what are the next steps to fix it?
Good question. As I said, lots of times it is the document. That's where we're finding a conflict. But there are tons of levers you can pull in any RAG system. So maybe you're updating the search methodology, making it more strict, less strict. Maybe you're updating the prompt. So the prompt has evolved over time, especially around our legal team is very specific about the language they use naturally. And so we have a lot of things that have worked itself into the prompt through their feedback of, hey, the one I always think of is, we had this process where legal would review and provide sign-off, but they wouldn't approve. Legal approval is its own definition, and that comes with its own risks. And so our model was saying approve. We had to basically instruct the model not to say approve unless it's explicitly in the document. You could review and provide sign-off. It sounds silly to folks, but it's actually a very important concept in legal. So that's one example. Any of those levers you might pull. So search, you might update the prompt, you might change the document store. A lot of times it's because of a document conflict between two teams, as I said, and so it involves setting up a call with them to see who is actually the process owner, who understands what's happening, and how do we rectify what's going on.
Yes, right here. Who are these stakeholders you speak of?
Yes, good catch. Those are our SMEs. Those are the stakeholders. And then also we would use sometimes a list of just frontline salespeople and we'd say, hey, go have fun with the tool. Tell us if it's working or not, as you'd expect. So mostly SMEs, but also some just testers.
We've got time for maybe one more. Yes, right here. So maybe semantic variance.
Yeah, I mean, that's one of the core challenges for sure. So on the question answer generation, that's where our prompt variation often comes in. So we'll say, create questions in this structure, or we'll take a question and answer pair that we know works and then run them through the model and say, give me 5 equivalent questions to this, so that we are getting that. To your point, especially in a RAG system, that's really important because a simple change in that sentence might actually yield to different documents coming out. And so that's how we're thinking about it on that end. And then, like I said, we also understand there's some natural variability to the model. And so that's what I mean. If we see a drop on one day against one document, we're going to mostly assume that's just natural variability within the tool. It's more when we're seeing it across multiple documents or we're seeing a very sharp drop, that's where we're going to be more worried. We're not, we'd love to have all 5s every day, 5 out of 5 on all our metrics, but we understand that that's just not going to happen in this space. And so we've built in kind of a comfortability of pretty good as long as it's not outright wrong.
All right, thanks again. And we'll leave it there. And our next session starts in 5 minutes.